So it seems like this should be pretty straightforward. The only place we can get a not R is from line 4 by a modus tollens. And to do the modus tollens, we need a P and a Z. Okay. There's a Z we can go after. And let's go after that Z first, okay? What do I have to work with? I have an A, but I notice this big hunk of junk that I need. All those pieces are connected together by ORs, which mean I can just add on what I need to the A. So first step, I could say this: A or B from 1 by addition, okay? And now I can say, well, to the A or B, I'm going to add not J. So that's from 5 by addition. So now look, this is the antecedent to 2, so I can do a modus ponens with 2 and 6, and that gets me Z. 2, 6 modus ponens. So I've got that part, so now I need a P, okay? I need a P. Okay, look at line 3. We have not used that yet. It is a negated disjunction. And whenever you see a negated disjunction or a negated conjunction, you should mentally apply De Morgan's and see what falls out. So let's just apply De Morgan, see what happens. Push the negation through, not P becomes P, or becomes and not Q becomes Q. So that's what we get from 3 by De Morgan's. And we said we wanted a P, right? So, yeah, we wanted a P, and it's in an and that's perfect. We can just say P from 8 by simplification. So now I have P and I have Z. All I need to do is put them together, P and Z, 7 and 9, conjunction, okay? And the reason why I got this is so I could do a modus tollens. See, this is the opposite of that, so I can do modus tollens and get the opposite of R, so I get not R from 4 and 10, 4 and 10, modus tollens, I believe. Oh, and we're done. Okay. 33. We have to prove Q and not X, or Q and P, and we have P and X, and we also have Q, okay? So one thing to notice, so I'm going to show you the way I'm going to do it, and then I'm going to show you a way a student in the last section said, can't you do it this way, which is a whole lot easier. So if you notice, we got a Q spread across a disjunction. So if I do distribution backwards, I get Q and not X or P. So I can go get the Q and then get the P and add or not X, and then combine these things, and then do the distribution, okay? So that's what I was gonna plan. But let me show you the student solution, which is much easier. Let's just get this P from 1, P from 1, simplification. Let's put these two things together. Q and P from 2 and 3, conjunction. Now remember, you can add whatever you want to something you've got. So we've got Q and P, and let's just add, let's just say Q and not X, and that's from 4 by addition. Now this is in the wrong order, but we can flip them, and we get Q and not X, or Q and P from 5 by com, and we're done. And that's much simpler than the way that I was going to do it. Okay, so 35. Not F if and only if G or not H. Okay. We have F if and only if G, then Q, and we have not Q, then H, and we have not Q. So notice that this is a negated disjunction. So if we push that negation through, it's the same thing as not F if and only if G and H. Okay? And I think I can go get those parts easy enough and then put them together. So let's first get this not F if and only if G. I could get it from here if I had a not Q. Guess what I have on line 3? Not Q. So I'm going to do a modus tollens, and I get not F if and only if G 1, 3 modus tollens. Okay. And now I need an H. Well, it's really easy to get an H from 2 and 3 by modus ponens. I get H 2, 3 modus ponens. So now let me put these two things together. I get not F if and only if G and H from 4 and 5 conjunction. Okay, and now I'm just going to do that De Morgan's backwards, which I saw. So I pull the negation out. So this turns to F if and only if G, and the and becomes an or, and the H becomes a not H from 6 De Morgan's backwards, as it were. And we're done. Okay. I don't know if I mentioned this, but there are 2 additional techniques to solving problems that I will introduce to you. One's called the indirect proof, and the other one's called a conditional proof. I will show these to you. You are never required to use them. Does everybody understand that? And none of the problems require their use. But they are very powerful, but it's also the case that they seem confusing at first, okay? So I will introduce them so that if you happen to do more logic, you will have been acquainted with them, but they are not required. And I will introduce them in the next couple of days. Whenever I see a problem that lends itself to using this other method that makes it easier, okay? Okay, 37. Prove G. One is not L then M or A then G. 2 is A, 3 is L, and we have to get a G. if we have this by itself, we can get the G because we have the A, okay? So to get this, it's in a disjunction, I would need the opposite of this, and that would be not L, then M, okay? So I think I can do this, L or M from 3 by addition, okay? Now what I'm going to do is I'm going to convert this or to a then, and when I do, the L becomes a not L, then M. That's from 4 by implication or material implication. Now, this is the opposite of this disjunct, so I can get A then G, and that's from 1 and 5, disjunct syllogism. And now I can just do a simple modus ponens to get G, and that's 2, 6 modus ponens. I know that I did it in some convoluted way in the other class. So this is very straightforward, simple. I don't know what the hell I did last time, but I know it wasn't that. It'd help if I ever just like type these up, the solutions. Okay. Q or R. And I have